I think the first time I gave a talk with a title like this was something like 13 or 12 or 13 years of design patterns. So I've been giving talks like this for a while. It's sort of changed into a talk about things that are wrong with the book. Partly because I've been trying to motivate myself to start working on a second edition. People were saying, you ought to do a second edition for the 10th anniversary. So people have been saying this for a long time. And we... But I'm going to be picking a few patterns in particular that are interesting that Smalltalk people know and talking about them. So the book came out, the date says 1995. It actually came out in 1994. It was Uppsala of 1994. We had been working on it for several years. The names are in alphabetical order of the four of us, but actually it was really Eric Gama's idea to start writing a catalog of these patterns. He had, in his PhD thesis, was looking at frameworks, and he had noticed these patterns that he saw in a number of different frameworks. So that was the start of our book. And then he got first Richard and then John to join him, and they were all working together. I had actually had a paper published at Uppsala on patterns. So as the only one who had actually published a paper on patterns, they wanted to include me, and they knew that I was interested in their work, so they asked me, do you want to join? And I said, sure, it's a great idea. I've never written a catalog before, so it'll be interesting to do that. And it's been a great experience, because the book has basically surpassed anyone's expectations for being popular. When Addison Wesley was negotiating with us, they said that they predicted that our book, that 10,000 copies was a really good number, and they thought that our book would probably sell like 20,000 copies. And for a while, we were doing maybe 40,000 a year. That was sort of the peak of it. And it's down now to about 10,000 a year. And it's still selling after 22 years. I still get royalty checks. It's just, my wife says, how can this be? That we just keep getting money, don't do anything, just keep getting money. It's pretty amazing.
He's just using all that money.
Yeah. Well, it sent several of my children to college. In the United States, college is pretty expensive, so it's good to have that money. Anyway, it's run all sorts of awards, and when we won the SIG Plan Award, I was trying to figure out why did SIG Plan give us the award? That's programming language. So the software engineering people, I could understand that, because I think it really is an important event in software engineering, but it's not an important event in programming languages. There are two possible reasons. It was at Uppsala, which is a SIG Plan conference, and they were always giving awards to people who had papers at other conferences. They actually made much more money off of Uppsala. Maybe they felt guilty, and they felt like we ought to give an award to somebody who publishes at Uppsala, and so they chose us as one of the big things that happened. Maybe that was the reason. But maybe one of the things that was important about the book was you had all these programming language people who were trying to come up with type theories and formal methods for object-oriented programs, and they would come up with examples that they would use their technique on. And the example would be something like, well, we've got a 2D point, and we're going to do inheritance, so we'll make a subclass which will be a 3D point where we add. This is like horrible design, and yet this is what everybody was doing in their papers, because they were theoreticians. They didn't actually have experience with object-oriented programming. Well, once our book came out, they all started taking the patterns from our book and trying to apply them, and it was actually much better, much more useful for us to drive practical type theories and all. So maybe that was the reason. That would have been a good reason to give. Whatever, it was nice to get an award. You never know what goes on in the committee meetings when they're discussing these things. But we got a lot of them. Something that even makes me happier is that this was the start of a lot of pattern books. There are a lot of people who wrote books that were basically design patterns for my favorite language. One for Eiffel, one for Visual Basic. There have been 20 different languages where people have written a book, design patterns for that. The first one was actually Design Patterns Smalltalk Companion. These guys worked very closely with us, and we thought that there would be a lot of these companion books, design pattern companion for different languages. We sort of advertised that we were willing to work. They were the only people who worked with us. It was an interesting experience because these guys are all very good Smalltalk programmers, mostly from IBM. And as we worked with them, and some of the chapters they sent to us were just wrong. And it's like, how can these guys who are so smart, who know programming so well, object-oriented programming so well, who read our book, misinterpret our book? Well, that was a good warning for us, because we were going to see lots and lots of people misunderstanding what we said. Of course, it's the author's fault. We're supposed to communicate better, right? We're trying. Now, the book actually had a lot of feedback. We had it. This was before the internet as you know it. The World Wide Web didn't exist when we wrote our book. That's how old it is. World Wide Web did not exist. And PostScript didn't exist. PDF didn't. We used PostScript, not PDF. We used PostScript on an FTP server, and then a mailing list. And we had 500 people on the mailing list that would put a pattern out, and then they'd discuss the pattern for a week or two. And we had a lot of feedback. So we felt like we really wanted to get it right. We were trying to get people. Now, what we were doing was just a collection of techniques that experienced object-oriented programming people knew. Nothing was new. None of these were new techniques. John Vlasidis thought he invented the visitor pattern when he was younger, but then he discovered other people had done it long before him. But those sort of things happen a lot. You sort of rediscover something. But so they weren't new techniques. But they were things that all four of us had seen. That was our rule. That somebody would say, well, here's a pattern. And if everyone else says, oh, yeah, I've seen that. Well, then we put it in the book. But people said, it sounds plausible, but I haven't seen that anywhere. Then those didn't get into the book. And we had patterns that didn't make the cut. And in the years since, we've discovered that some of these patterns are really not that important. They're rare. They don't actually happen too often. Other patterns are very, very common. It was hard to tell at the time because, sort of the four of us, based on our experience, and one's experience is always limited. It's your experience, whatever that is. So that first book up there is an example of a book that is just for another language. The Heads First Design Patterns is a great book for Java. In particular, it's more of a tutorial, and doesn't cover all the patterns. And they try to tie the design patterns into design principles, which I really like. And if we do a second edition, we're going to tie the patterns into principles better. We didn't do a very good job of that in the book. There are other books. One of my favorite pattern books is Domain-Driven Design. I mentioned that yesterday. Martin Fowler has written several. There's a lot of people who've gotten into writing patterns. And the great thing is, when I want to go learn a new area, if I can find a book where some expert in that area has written a lot of patterns, I can learn that area a lot faster. That's sort of the purpose of pattern books, is to help people learn to become an expert faster. Now, it used to be, in the old days, people talked about how patterns were sort of condensed expertise, and that you could become an expert by reading the patterns. That is not true. You cannot become an expert by reading anything. You have to practice. The patterns tell you what to practice. So you read the book, you practice, you try it out, you'll become an expert faster by reading the book. But you won't become an expert until after you practice what you read in the book. So, and my summary is that the book is obviously a success and has had a big impact. You listen to some people, especially 20 years ago, people talking about it. It was as if the book had somehow descended from heaven, and we knew it was not like that. But it's a pretty good book, and it's had but I'm interested in how can it be better? And there's lots and lots and lots of ways it could have been better. And so I'm just going to talk about some of them. And in particular, I've selected things I think that Smalltalk people will be interested in. Now, why did we give bad advice? Well, one reason you give bad advice is that times have changed. I mean, we're talking about before Java. Java came out basically a year after our book came out. Before the internet, people have built software differently. And we have learned some new design techniques since then. But it's also the case that we've learned to talk about design. The book got lots of people. I say the great thing about having all these books is there's now a culture of talking about design that we didn't have before. And our book wasn't the only thing to cause that, but it helped that along. That's great. But there are places where we really just should have known better. We should have been able to say better. I can look back in retrospect and say, I knew all this stuff back there. Why didn't we put it in the book? One of the things we have in the book is it divides up the patterns into 3 categories. Structural, behavioral, and creational. And some people seem to think that these are significant. No. We started out, we had a list of our 23 patterns, and we said, 23 is too long a list. Nobody wants to look at a list of 23 things. We have to have smaller lists. We must break it up. We started off by breaking it up into 6 lists. We had some sort of theory behind it. We have these 6 categories, but it turned out like one category didn't have anything in it. That's pretty stupid. So anyway, we went through until we got these 3, and we were happy with it. Okay, and it works okay for the book, but not that useful for people. And in particular, behavioral and structural are hard to tell apart. There's patterns I think you could argue are either one. Creational is a nice, well-defined category, but the other 2, it's sort of vague. But we actually had a meeting some years ago where we were talking about doing a second edition, and we didn't like these categories, and we came up with a new category. We're going to call them core. We're dividing up the structural and behavioral and said core and peripheral based on how important they were. Well, we had no idea how important they were when we wrote the book. So we couldn't have done this back then. But now we can. We can say these are things everybody should know. These are patterns that are less important. Then we have the creational ones. And we also have patterns that we think of are really are compound patterns that you're combining other patterns to make them. A couple of our patterns are really more complicated, I think, than people realize. Okay, so the core patterns, we actually, I think null object is one that we would put on here. So on these slides, I don't have we have a list of like extra patterns that we'll put in for the next book, and null object is one that should fit here as something everybody does. I'm going to talk about. I'm actually going to also talk about Mediator a little bit, I think. Iterator and Observer are the ones I'm going to talk about the most. I'll mention Composite and Mediator. Okay, so Observer. Observer, define a one-to-many dependency. And I wanted that word dependency in there because in Smalltalk, of course, it's called the dependence mechanism. Define a one-to-many dependency between objects so that when one object changes state, all its dependents are notified and updated immediately. So in the book, every pattern we try to have this very succinct description, which we, if you actually understand it, it means you know the pattern. People will think, I'm going to read this and then see that and they'll tell me what pattern. No, it's a very short, brief description of it, and usually when you start reading it, they all look sort of the same, and it's hard to tell what they mean. But that just shows you haven't learned the pattern yet. You go through, read the chapter. When it makes sense, then okay, then now you sort of know the pattern. So there are these 2 roles, subject and observer, where an observer is the subject is a thing that's changing state, and the observer is depending on the subject. And my little example here is a simulation of FBI agents who are spying on mobsters. So this is 1920 gangster classic. So you've all seen the movie. So they're across the street with binoculars, and maybe they are wiretapping the telephone. That's the classic. And of course, the mobsters don't know whether the FBI agents are watching them or not. But but the FBI agents know whether they're watching the mobsters. And so the protocol is that an observer will perform an add-dependent operation on the subject. And the subject actually has a list of observers. And that when the subject changes, so in the implementation of rob bank and drive car, you will have self-changed. In Smalltalk, it's self-changed. And that actually notifies the observers. Now, if you're thinking about the mobster FBI scenario, what this means is that every mobster carries around with him a list of all the FBI agents who are watching him, and every time he does something suspicious, he has to tell them all. And that's very bizarre. That's exactly what happens in the observer pattern. It's exactly what happens. And so this is a nice thing to think about, because that oddity of... Now, so there's this add-dependent... Every observer has to implement the update message. Observer is actually an interface, because that's all observers have to do is implement this message. Okay, so there's basically the three parts of it. There's registration, where observer gets added as a dependent to a subject. Notification, where you say self-changed. And then the update, where you implement the update operation. So self-changed on the subject causes update on the observer. And that way the observers know that the subject has changed its state. Now, there were a lot of C++ systems back when we wrote the book that did pretty much the same thing. And this is the way Smalltalk does it. Smalltalk, there's always these variations. So, for example, those of you who've looked at this in Smalltalk know that it's not actually the case that every object in the system has a list of observers as an instance variable. It's the model class introduces that. Instead, if for a default object you want to put an observer on it, that holds a class variable up in class object that keeps a dictionary of the mappings from one to the other. So it's sort of messy and can cause garbage collection problems. But the idea is the same. It's just a variation on that. So this is an accurate design. This was a C++ version of it we had in the book. And the same thing, you've got class subject, class observer that implements the update operation. Now, what happened in the Java world, though, was sort of funny. And actually, because C++ did it that way, Smalltalk did it that way, Java is sort of halfway between C++ and Smalltalk, so you'd think that it would work perfectly fine for Java. And actually, the very first version of Java, the very first version of AWT, had observer just the way I describe it here. And it didn't work very well. And I don't know exactly why it didn't work. I think it's because they tried to make it in C++, even though people would use the pattern, they didn't try to make reusable libraries out of it. And then in Smalltalk, we have dynamic type checking. I think it was that combination of having static type checking and then trying to make it be reusable, and it just didn't quite work. And so they came up with listeners. So in Java, what you're used to if you've done Java user interface libraries is you have these listeners, but the very name listener, observer, you can tell they were thinking, it's not quite the same. It's a little bit different. We'll just change that name to let you know it's a little bit different, but it's still basically the same pattern. And that's why I think listeners are basically observers. It's a specialization, maybe an improvement, a little change to the pattern. So the idea is that the update method takes an event as an argument. So in Smalltalk, you can pass anything as an argument in update, and it all depends on your application. The standard thing is to pass a symbol, but you can do anything. And I had actually seen places in the past where they created a little event class, and you would pass events along in update. I had seen that by the time we wrote the book. I just hadn't realized that it was significant. I hadn't said, this is something that is a good practice. go back and look at the book, not a mention of that in the book. So you have an event object that gets passed, and there's a lot of different kinds of event listeners, and each has its own interface. In fact, an interface can have more than one update method. Most of the time they don't, but they can. They can have more than one. So here's a few of the ancient Java interfaces. Most have been around for a while. And so action listener, property change listener just have a single update method, and then component. Notice that none of them are called update, right? They're called something else. But they do the exact same thing that update does. It's important when you think about patterns not to get too confused or too persuaded by the name. Sometimes something will have a name. You'll see something that's called a strategy, and you look at it and say, that's not a strategy. Why did they call that thing a strategy? And the same way, it may not be called a strategy, may not be called an observer, and yet it is. You have to understand what's going on and understand the pattern to see whether the names match. So in this case, these are listeners. They have these I say it's an update method because when you implement a listener, you have to implement these operations. This is what you do. Okay, so the book says this, and this is a quote. And this is sort of the closest the book comes to talking about this idea. It talks about a push and pull model. So a push model is that when you get an update message, all the data you need is then passed along as an argument to the update message. Whereas the pull model, you get an update message and you get a little information. You then have to go out to the subject and ask the subject for what you really want. So that pull is when you'll have two messages. First there's the update, then you go out and you ask what you want. Whereas push, there'll just be a single message. And the problem, of course, is you have to figure out in advance with push what the observer will need and make sure you pass everything along, and that's hard to do. So their comment here was that implementation of the observer pattern that often broadcasts additional information, and the amount of information varies widely. The pull model emphasizes the subject's ignorance of its observers, whereas the push model assumes subjects know something about their observers' needs. So you know what they need, you're going to pass that up to them. So the book wisely, mistakenly, concludes the push model might, that shows we're not completely sure about what we're saying. Whenever you see somebody say might, that's waffle language, and that's American, and they say that's waffle language. It might make observers less reusable because subject classes make assumptions about observer classes that might not always be true. Well, that's a false statement there. Reality is push model makes observers more reusable because what you'll do is you'll have to understand the kind of thing that changes. You make an event object that completely describes that change, and then they only have to undertake the event and do that. So, in fact, one of the changes in observer pattern is having standard protocols, or standard types of events that we're going to have, and that way, and even in visual works. So this was, I should have been able to see this in visual works at the time that we wrote the book. This was present there because they have the holders, and then you have objects. Once you have a holder, you can have a different type of views of that holder. And by having standard interfaces there, so something like observing a string or a number, you get libraries. Standard libraries of user interface parts that get plugged together, and it happens by specializing the observer interface. And that was all done without making listeners without going as far as listeners in Smalltalk. So you don't actually have to go as far as that. But listeners make that much easier. That's one of the things you see in the Java world is different kind of listeners. You build different standard listeners that use that interface. And I'm using a library called Vaden, which is a Java library. They call it data binding there, but actually I was talking to Eric Gama, and he was telling me changes of it, and he whatever library he was using, they called it data binding there too. So I don't know if data binding is the only name, because it's not a name I've seen in the Smalltalk world. But it's idea that we're going to break our big model into these smaller models, and then they're standard components, and then you can automatically map. That's the binding. You automatically map the data to the user interface, or user interface to the data. So if you have primitives like properties, lists, and so on, and now you don't say, we're going to assign to a variable. Instead, you are setting value of property, and then you have something that's looking at that property, and it can automatically update. Now, again, VisualWorks was doing that in 1994 when we were writing the book. So this is not not something outside my experience, but we weren't thinking this way. Just as a, and I say that I was looking over Squeak to try to, and Squeak doesn't really do this. The Morphic isn't built on this type of property, so it's not something that is taken over the Smalltalk world or anything like that. But I'm saying there are pockets of the Smalltalk world that were doing this. So you have a big model that's broken up into these smaller models, beholders, representing a string, a list, another string, and you can use standard UI components to plug them together. So advantage of doing this data binding is that you don't have to say this invoke update event. You don't have to say self-change. You don't say self-change anymore. You just set the value of a property, and it automatically tells that it was changed. Actually, self-change is not a problem. It's not a hard thing. People don't. That's not the kind of mistake you make. But it is sort of nice not to do that. The main thing is your observers can be reused, and you have a library of reusable observers, and then people start plugging things together to build your user interface. It just makes building user interfaces a lot easier. But you need a set of standard interfaces. So if you have a system like this and you have a problem, like when a new file name is selected, the file is read, its text is displayed in the lower text box. How do you implement that? You can't implement that in any of those single user interfaces. It's a higher level thing. Keeps dropping out. So it's a higher level issue. And so what normally happens is you will have the maybe the overall window will be a listener for that change. And when it gets it, it will then coordinate between the different. Now that turns out to be I'll come back to that. That turns out to be a mediator. The reusable observers handle a lot of what you want. You've got these things that don't fit, and the usual thing is that you propagate that up to some higher level object that handles all the miscellaneous things that your library isn't handling. So the application specific things are going to be handled at that level. And that's the mediator pattern. And typically the mediator is either the topmost model or it's a high level view, or depending upon your library. And the book actually mentioned mediator as being related to observer. But if you aren't reading very carefully, you might even think it was talking about it. It's not talking about it. It's talking about something completely different. It's talking about something completely different. What it says is you can make a change manager, and that every time you do an update, you basically notify the change manager, and then the change manager figures out who to actually notify. And this is much more like the announcement system in Pharo, and I guess VisualWorks has that too. That's really an example of encapsulating the observer pattern with a mediator and uses change manager. So it's describing that. It's not describing what you normally see, where you take your high-level model and have it observe the components so that you can do this. The 5% that the library doesn't do for you, the application-specific stuff. So I want to say one thing. There's Microsoft has written some patterns books, and one of the cool things they did in their books is for every pattern they talk about how to test that pattern. If you have code that uses this pattern, how will you want to write tests for it? What are the kind of mistakes people tend to make? And that's really useful. And you have to know the pattern pretty well. We couldn't have written this when we wrote the book. I can write it now because I've seen people make huge numbers of mistakes with patterns. I've made mistakes. When you make the same mistake over and over again, you say, oh, this is a little bit harder than I thought. And with Observer, there's basically 3 types of mistakes. You can implement the update method wrong. The most obvious way is not to implement it at all, of course. But that's really obvious because you're looking at the screen and nothing happens, or it does something weird on the screen. So if you make mistakes there, you can spot those errors pretty well. And another one is you're missing the call to the change. And so what happens there is that you perform an action and something's supposed to update and it doesn't because you never notified anybody. Again, if you're using the data binding pattern, that goes way, way down because you're not explicitly calling changed anymore. And I guess I never thought of this as the really hard. Even if you weren't using data binding, this wasn't necessarily the hard one. The hard one was the third, where you just never bothered to set up the right dependence. But now, if your dependence is very simple, then you're not likely to have a problem. But I often build systems where we're like adding and removing dependencies, and when you do that, it's easy to make a mistake and not add them when you're supposed to. I've always thought that the third one was the hardest one to find, and that it would be smart if when we built these observer libraries, we put debugging features in to help us figure out that connection. Okay, yeah, I guess Okay. I'm about halfway through, right? Yeah, okay. Okay, so that's Observer. Now I'm going to talk about Iterator. Now, this is sort of from the book, the picture of Iterator. And Iterator seems like it's a more important thing if you're in C++ or Java, where they talk about it. Not so much in Smalltalk, but if you actually read the book, what you'll see is it talks about both external and internal iterators. So it says that even in this case where you just say some string do, that is internal iteration. So that's an example of the iterator pattern too. What's really important is having an interface for iterating and making that be a standard part. And when you build some object, you provide and you implement that interface. You provide some implementation for the interface for iterating. And we talk about 2 different ways of doing that: internal versus external. Internal, you need blocks. You need some way of something like closures, some way of having code. External is a stream. So in Smalltalk, we have streams. And I'm making a stream, a read stream on a string, and then we can loop over that stream and basically do the same thing as you had before. Now, this is a good example because typically doing it directly with do is simpler than writing a while loop. So if you can do it directly with the collection interface, that leads to simpler code than using the stream interface. But there are things you can do with the stream interface you can't do with the collection interface. There's times when the collection interface is not enough. So, of course, the collection interface is more than just do. We have do, select, reject, collect, inject into. And these are, the names all rhyme. They actually were chosen to rhyme. I think injected to is a weird name, but it was chosen to rhyme because once you get on a roll and you have all the others, you want it to rhyme. But
it's from the song Alice's Restaurant.
Yeah. Sometimes it's from the song Alice's Restaurant, and sometimes I actually play the little clip so that you can hear those lines. But it was actually a little bit old for me. I mean, it's not. So for a few young people never heard it, it's not surprising. Okay, so I'm programming in Groovy now. And Groovy has collections, sort of a limited supply of collections. They have lists and maps, and that's really the only ones. They have some more, but the others aren't very well supported. Lists and maps are what everybody uses. But on them, you can do each instead of do. They call it each. There's collect, which is the same as smalltalk collect. Instead of select, they call it find all. And then instead of inject into, they call it reduce. Actually, I think reduce is a better name. Find all does not impress me as a name. It always seems weird. So, and collect. And you can define those methods on streams, not just on collections. You can define them on streams as well as collections. Now, and that's an interesting question. Because streams in Smalltalk implement do. Why can't they implement select and collect? Well, they do in mine, because that was something I learned a long, long time ago, was to make a select stream and a collect stream class. And so when you say select to a stream, it gives you back a select stream that will just pull out the individual elements. So when you say collect on a stream, it gives you a new stream that transforms it. So to me, it's streams and collections are pretty similar things. We ought to think about them more similar than we often do. Inject into is problematic because it assumes a finite length. And if you have an infinite stream, again, I have integer stream that just counts forever. So if you have an infinite stream, then inject into doesn't work too well. There actually are people who do stream languages have something that's similar to inject into, only that operates on infinite streams. So there are ways around it, but I don't want to get into that. JavaScript has the same thing. JavaScript has for each, map, and filter, and reduce. So map is the same as collect. Filter is the same as select. And there's this quote from one of the papers on JavaScript stream libraries that support this. They say, event stream. So originally there's a class array. An array had these operations, and they didn't really have any other collections. Just array. And then they made these streams, and they made streams have the same operations that array did. And they said this, event stream has all the array functions because an event stream is like an array, only laid out in time instead of memory. And if you don't understand that, think about it real hard for like several days. And when you understand it, lights will go off in your head. It's a brilliant observation. Even Java now has them. So Java 8 with streams has come out with them. And again, what's happened is now that Java has closures, then it's sort of easier to do this. And so all this stuff comes along with it.
I'm sorry.
Yeah. It doesn't matter. It doesn't. I mean, Smalltalk's blocks aren't. It doesn't matter. It's having code as objects and being able to pass as code as values and pass around. That's what's really important. Okay, so what the book missed entirely, we missed it completely. And any Smalltalk programmer who thinks about this long enough should know this is true. Is that a stream is a kind of iterator. In fact, I go back, I can't find any of my notes on object design using Smalltalk that do not say that a stream is a kind of iterator. So why didn't they put it in the book? I have no idea. Okay, and you can define map, filter, and reduce on your iterators, even without closures. It's really ugly. You build these basically a strategy objects. You have to build past them. I mean, you can do it. It's ugly. When you have closures, it becomes easy. It becomes easy with closures. So if your language has code as values, whatever, whether they're pure closures or not, it doesn't matter. If they have codes as values, then you absolutely should do this because the benefits are immense. So there's all sorts of in Smalltalk, we program this way because it makes our programs cleaner and simpler. That's why we do it. It eliminates all sorts of errors. Now, an interesting thing is, it's actually, there's ways of doing parallel programming based on programming this way. So if you program this way, in theory, this is certainly just true with GPUs. There are GPU languages that are based on this. So one ought to be able to take code that does everything this way and transform it into a GPU code. I don't know of anyone who's trying to do that with Smalltalk. I actually had a PhD student who did that with Python. He was compiling Python code to the GPU, and he was doing it by having parallel. Going back to programs are shorter, it looks more like straight line code, and of course it isn't really straight line code. You have a single line and there's a whole loop in there. Who knows how long that loop is taking? It could take a really long time, but it looks straight line. And that's a way when we send a message. Sending a message is sort of like this gigantic if statement where you don't actually know, depending upon the class of the receiver, who knows what code is going to be run. But we don't think about it that way. The intellectual content of just a single message, it seems like it's simple and straight line. Okay, so this was stuff that I, in retrospect, think we should have had in the book. Like, why? This is something that is part of the Smalltalk culture, and I think part of it was that we were writing to C++ programmers. I mean, our target audience was not Smalltalk programmers because there were hardly any of them. Whereas our target audience was somebody who had been programming in C programmer, who had been programming in C++ for 2 years and had just discovered he was not doing object-oriented programming. There were huge numbers of them. And so we were going to say how you can actually do object-oriented programming in C++. But now I'm going to get into something that when I saw this, I was blown away. So this is incredibly cool. Unfortunately, I mean, it'd be nice to say Smalltalkers did it, but it's not true. It was actually, I think, JavaScript people did it the first time. But it's an idea that follows very closely and fits perfectly well into how Smalltalkers do things. It's just part of this. It's sort of the next step in the observer pattern. And it combines Iterator. It combines Iterator and Observer. So, it's called Reactive Programming. So you can Google this and you'll see various libraries that do reactive programming. Okay, so the idea is, think of a subject as a stream of events. A subject produces events. And an observer now is a function. It's a filter of some sort on that stream of events. So it converts that stream of events into maybe a different stream of events. And if you think this way, which I'm not going to try to teach you how to do it, because I've actually never used a library that did it myself. I've only read these stuff, and again, because I've done so much with Observer, it was easy for me to understand it. A lot of you guys haven't really done that much with Observer, fiddled with it a little bit on some user interface. But it has these benefits. The main thing is, when you have synchronization between different event streams, that's very hard to do in the observer pattern. You often have to have a little state machine that handles events coming in at different times and moving stuff back and forth. Error handling. Having things that, in some sense, you're in the stream, but then you also have these errors that happen that force you to change everything and need to be out of the band. That's hard to do, leads to complicated code in the normal way of doing observers, but it becomes a lot simpler with this. So I'm going to actually show you some JavaScript. And one of the things about this stream processing is that they add a whole bunch of new operations to collections, to streams. And some of them are, so the thing about select and collect is that they're deterministic. If you do select on two streams that have the same value, you'll get results of the same value. Take until is non-deterministic. It's taking two different streams, and the order that things come in on the streams determines what the result's going to be. So that's sort of weird compared to the classic Smalltalk one. So there's concat all, takes a list of lists, and then concatenates them. So it returns a single list of those things, whatever that is. And then you have a take until, a stop stream. So you perform take until on a receiver, and it gives you a section of event. So you could have an infinite stream, and you do take until something, and it turns it into a finite stream. It gives you just a prefix up until some event happens on the stop stream. And once the event comes in, it stops and returns that. So it's non-deterministic. Okay, so this is supposed to be a mouse you're trying to code up a mouse dragging something. That's what you're trying to do. You're trying to have a function that gets performed on some element, and this is JavaScript. So the name of the function is getElementDrags, and it takes an element as an argument. And then on the element we do mouse downs, and that gives us a stream of mouse down events. And then we do a map on that. We map each mouse down event to I'm thinking. So we're then I think element and document. Maybe that should be the thing. I think document should have been element as well. I think I renamed it and didn't get all those, because then we ask for the mouse move. So the mouse is down, and we're getting a stream of all the points that the mouse moves at, and we do take until the mouse goes up, and there's a stream of all the mouse up operations. And so you take until that. So when the mouse comes up, then you stop. So what that has done is we have all the points that have come in, and that happens for every mouse down. So we do the concatenate all to get the whole sequence of points, and then we are doing for each on. So that's getElementDrag. So we call getElementDrags on the image. That gives us all the points of where the mouse was supposed to be on that image. And for each one, we set the position of that image to be the position in the stream. So we've gotten this stream of where the mouse went, all the points that the mouse went, and we're basically setting the position of this image to each one. So that's an incredibly short piece of code for doing that. It just sort of shows what, and it would be easy. Somebody for a class project, you could do this for Smalltalk. It's not going to be very hard to build a reactive library for Smalltalk on, because we have all the mechanisms, all the steps. So it's an idea for a class project for somebody. Okay, and if you do reactive extensions, it was a JavaScript group at Microsoft. Netflix is using it big time, and they go around and give talks about how wonderful this is. There's Java libraries. A lot of people are making libraries that have this now. There's YouTube videos and all. Okay, so my sort of retrospective of how observers should change is we should have talked about passing events as objects, and how passing events as arguments is a good thing. We should have talked about the sort of data binding of having standard interfaces, so you can build standard libraries of observers, and that eliminates a lot of what. We should have talked about Mediator. I deleted the slide that talked about adapter, but there's sort of a standard way of using adapters with this. And then how you can simplify the complex observer logic by treating event streams as a stream, and you treat it as an iterator, and then you can use collection operators like map and filter on it. I'll just say that the Smalltalk names were great when we didn't know better names, and I'm not actually suggesting we try to change them, but in terms of people inventing new languages, map and filter seem to be the names that are coming out, and those are pretty good names, nice and short and easy to remember. So I strongly recommend that that in Smalltalk, you really try to program with collect and select. You have to teach yourself not to, to use those and see how to break an expression up into it. You'll get this nice straight line code. You should, when you're doing that, realize that's the future. 20 years ago, I couldn't tell students that. If we were programming with collect and select, what's nice in Smalltalk, you go program in Lisp, like what's the odds of that? You program in Lisp, you can do it too, but any other language you use, you can't program this way. Well, that's not true now. Now, all the languages are going and programming the way that Smalltalk was doing it 30 years ago. And we also talk about Iterator. We should have mentioned that all these other operations on Iterator are a key part of the Iterator interface, and that streams are iterators. Okay. In general, there is sort of, the book, I think, has too much emphasis on the individual patterns. Patterns are actually sort of step in your design process, and that's something that, and also, patterns are not in and of themselves good. People often like to say, well, this is a good program because it has a lot of patterns in it. That doesn't, you can't tell whether something is good. Were they the right patterns? Were they it is good that you sort of followed standard convention, but people will sometimes put patterns into a program just because they've always wanted to do it, and this is a good excuse to put the pattern and use the pattern. They can tell everybody they've used it. And that's actually useful from an educational point of view, but it's not useful from a point of view of making good design. You want to make sure you really need it. So I'm about done, right?
I think 15 minutes.
15 minutes, okay.
A little bit less.
Okay, so I'll try to finish up in 5. I want to have questions, so I'll try to. The question was, I don't say that much about composite. I'll go through composite real fast, and then finish, and we can have questions. So composite. The composite pattern is. The problem is that you have this abstract component class. You want to build up a tree of these components. And one way you can do it is how Morphic does it. Morphic has Morph, and that's the component Morph. And every Morph can have submorphs. So Morphic does it this way. This is not composite pattern. It's not quite composite. And then you have all these subtypes down below, subclasses, and all the different submorphs. And the problem is that, in fact, when you start using the system, you discover that some of these patterns, or some of these things like we have chapter and paragraph, something's going to be the smallest object, and that won't have children. Is my battery going out? We'll try this one. And it's like a classic bug. And the original model view controller was like this. And people were always trying to, by mistake, add a button to a text view. And it just didn't work. It just didn't work. But the system will let you do it. There was nothing in the design that prevented it. So the true composite pattern is like this, where we're going to say we have a component, and the component has operations to iterate over your children. But in fact, there are some classes, these leaf classes. So the subclasses are two types. There's leaves and composites, where the leaves don't have children. They cannot have children. You can iterate over the children because iterating over an empty set is easy. But they don't have children. Now the problem always occurs is, what about add child and remove child? How do you implement add child and remove child? Do you put those down in your composite and then forget about it? So basically a composite has a different interface than a leaf? Or do we say that add and remove are up on the superclass and we generate an exception? If you call add or remove on the leaf, it'll give you some sort of error message. How do we do that? Do we have two different because the whole point of composite, of this component, is you want a single interface. We want lots and lots of objects that have the same interface. And if now we say some of them have an add operation, some don't have an add operation, well, those are different interfaces. Yeah. What the book actually says, and this was something that we argued about a lot because I took the Smalltalk position. And the Smalltalk position is you just put add and remove on the composite and don't worry about it. And you can do a little check. Sometimes you have to actually do a runtime check to make sure but most of the time you don't. Most of the time it just works itself out and it's not a big deal. Whereas in C++, they did it the other way. And so I lost that argument. And the book will actually tell you that you should put the interface up on the supertype and then have like an exception down. You implement the method in the subtype to have an exception. But interesting thing is, if you look at all the C++ libraries now, they don't do it that way anymore. And the reason was that C++ got runtime type checking, a type safe downcast. And once you have type safe down, it changes that. So there's a case where some little language feature actually determines how you apply a pattern. The book is, it's 1994, state-of-the-art C++ from 1994. So it tells you that. So there's a case. Actually, I think it's the only thing I remember where I argued and I lost and I ended up being right. So I remember that really well. I remember that very well. Okay, so this is the child management, and anyway, it really should be in the composite. So like I said, we had people who were squinting at me from a Smalltalker's point of view. Well, it's obvious. This is always the way we do it in Smalltalk, and that was what I was trying to argue. But like I said, they could point to 7 different C++ libraries that did it the other way. This is clearly the standard way of doing it in C++. Okay, we'll go along with it. So type safe downcast is actually pretty important. Okay, so our summary is, actually as time goes on, patterns change. Languages change, and so the patterns we use are going to be different. And there's nothing wrong with that. It's actually amazing how much hasn't changed, how much these patterns have stayed the same. But we do need a new second edition because things have changed. Things like concurrency, people at Plop, somebody was talking about security of certain things. I mean, these issues come in and they do affect it. We shouldn't just think of patterns as sort of endpoints of refactoring, but as steps along the way. And the real purpose of what we're trying to do is, of course, build systems. We want good design of systems. The patterns are a means to an end. Actually, Christopher Alexander, who was this architect who wrote books on making buildings and had these patterns books that were influential to us, he made the point that patterns were not the way, they weren't the end, they were just a gate to sort of get us to the way. They're a teaching aid, they're a tutorial, and you follow they're good for communicating with people, but they're also good for learning. But once you become an expert, you learn, like any good musician knows when to break the rules. You learn when to break the rules. You don't always have to do it the way the patterns say, but they're good for teaching you. And I'm always happy to talk to people. It's on my first slide, but it's here as well. So I'll take questions.
Hi. You mentioned that you believe that some of the other languages are catching up to both in the style programming. Do you think?
So I was only, what I said that was very specifically about using collect and select, that type of thing on collections. There are people in the JavaScript world, there are people who say this is how you ought to program. So I assume that they themselves program that way. I don't know how many, clearly the fact that they make a big deal about it means that most people don't. So I don't know what fraction of people actually do that, but I predict that over time more and more people will program that way. And what it means is that if you learn how to do it here and then you go off to those other languages, you can keep on programming that way. That's really what I meant.
My question was, I was wondering if you think that makes these languages now usable for teaching good object design, for example.
You can So one of the great things about Smalltalk is that you can almost not know good object-oriented design, and you can let students use it, and they can sort of figure it out on their own. I mean, it's a good self-teaching tool. Because I think that if you know what you want, and you're, in terms of teaching, you can take this about any language, and you cut out the parts you don't want them to see, and you tell them rules, and you're fierce at how you give feedback and grade things. And you can use, because design is not limited. There's a saying, it's a poor workman who blames his tools. Now you can do good work by it's obviously easier in a system like Smalltalk, but as the fact is that these are the languages that people use, and you want to learn how to use them well. So I think it's good to teach in it. But I mean, I always taught object-oriented design with Smalltalk, even though almost all of my students would never use Smalltalk again until after the class. But that didn't matter because it was such a great teaching tool, and it still is. So the question is, when will these other languages catch up and be as good a teaching tool? I have no idea. Yeah, I can believe that they're not at the moment.
When you showed us the reactive programming slide, the code example, I couldn't really understand the things there, and I think it's because I was thinking on the screen as blocking or requesting the next element, and I think that sort of programming requires on every reaction you assume a new thread, let's say. Something like that. Is that correct?
Well, it doesn't actually create a new thread. You can think about it as creating a new thread, but it's not actually doing that. You really should think about this as a stream of things that have, it's like you're outside of time, looking into time, and you notice that there is this sequence of things, and you're going to apply some function to this whole sequence of events and transform history into something else. That's the way you're supposed to think about it. It's a different way of thinking. It requires it, but it ends up with these very simple programs.
I understand that for the map, but if battery is the up to and then the stream next in the argument, and that will block everything. Like us.
You're worried about how you implement it.
Yes.
Yeah, I'm not quite sure how you implement it. I would grab one of these other libraries and study how they did it. There's probably some mailing list of the guys who implement these things where you can talk about the tricks there. But yeah, it does seem like there ought to be a thread in there. I don't know though. Yeah.
Hi. So these pattern things, since you say they are able to reach the design, when I look at it in terms of, well, they are this transfer object in the same way that Noah's turtle was a transfer object with the geometry map and so on. And you say, well, it's no way to learn the design. So after all these 22 years of design patterns, what do you think are the main characteristics that you can recognize in good design beyond using patterns or not? What does good design look like?
So
if you see it, how do you recognize it?
So actually, the object-oriented community has a good set of principles. So yesterday, somebody mentioned the dry principle. I mean, there's a sort of a solid with single responsibility, and when I teach, I always refresh my memory what all those things mean. But those are actually good principles. And like I said, one of the things I like about the heads first patterns in Java is that they relate principles to patterns, and they show how these patterns are examples of the principles. Well, when we wrote the book, we didn't know that. We hadn't thought about that. A lot of the principles have sort of come out and been, and those are one way. But the problem with principles is that it's easy to memorize a principle. It's a lot harder to figure out how to apply it to the particular thing you're in. It takes practice. After you've done it a lot, then you can apply it a lot better. And the patterns are more concrete, and they focus on a particular way. So they are, when I teach my design course, I will give homeworks where I will say, here is a particular problem, use this pattern in it. Use this pattern in it. I sort of tell them the patterns they're supposed to use, and they get to practice refactoring the code to put the pattern in. I always have a case where I tell them a pattern that makes it 3 times more complicated than it needs to be. Because it's important to learn that the patterns aren't magic, that you need to be able to evaluate, is this really improving my design? You look for good examples where it's pretty obvious. Sometimes it's hard to tell. Is this better? Is it not better? What's better for this? And it's worse for that. But sometimes you can have examples that it's really clear. And that's a way, normally when people are learning design, they can do a little bad and it doesn't bother you. But you get bad enough and now you can't make changes to your system anymore. And even a person with very little design experience can recognize that this is a bad situation. So I used to teach a 2-semester software engineering class. And we had some people in the class who were graduate students. Mostly it was undergrads. It was mostly undergrads. And the graduate students in our own program who would take the class, it was always very easy for them because they usually had been practicing software professionals for some number of years. But we had some people who were officially grad students. They were from India, and they had degrees in some other field, and they were basically being cross-trained into computer science. So they were all educated and smart and so on, but not very much programming experience. And so as they were how do you teach a design techniques to somebody who doesn't have much experience like that? We were sort of using an XP style, and what would always happen is they would take a feature, write code, write test, write code. Take a feature, write test, write code. And then, of course, we told them to refactor. When your design gets complicated, refactor. But they had no clue. They couldn't tell if the design was getting complicated. They just keep adding stuff until it was so hard to add anything else. And they said, this is getting really bad. And well, this is why we told you to refactor. This is the great enlightenment occurs, and that they would end up with something that worked and wasn't too horrible. Obviously, weren't able to do as much as the people who came in knowing more, but having the time to sort of make the design mistake and fix it was really important. And I think that in general, when we're trying to teach design, we need to show bad design, not just good design. Students will generally generate their own bad design if you give them enough time to then fix it and wrestle with these ideas. That's very important for teaching the design. So getting back to, these aren't principles. Patterns are not principles. Patterns are sort of common things that occur because the principles sort of force it out as this being a useful thing to do. Figuring out the limits of a pattern. Where does a pattern start making, like someone was telling me, the observer pattern is too slow. Well, it turned out they had like 100,000 observers in their system. So I could imagine that it would be too slow for what they were doing. You can abuse any of these patterns, and then it doesn't really work.
Okay, one last question. I'm going to make.
Okay.
What is called the singleton pattern? Is that a pattern?
Excuse me?
The singleton.
Singleton. Well, I'm going to talk about that actually at Plop.
Okay.
The singleton pattern is probably the pattern that's most abused on the internet. If you Google problems with singleton, you'll just get page after page after page of people telling you things that are wrong with it. And by and large, they're correct, but it's like irrelevant because there are cases where the singleton pattern works really well. So the purpose of the singleton pattern is to control global state. Now, ideally, you wouldn't have global state. Okay, so often people will just use it as an example of blessing global state. So they, rather than figuring out how to get rid of global state, they'll just put a singleton around. I can remember going to a conference, and after the book had just come out, and someone coming, oh, we're starting to use your book, and we've got in our system we've got 17 singletons and 20 mediators. That's like, oh, come on! How could you, if somebody come and told you how much they love your book? You can't tell them they're stupid. I can't. Yeah. So, and one of the things that taught me was that our book doesn't say enough things about the dangers of singleton. It's too optimistic, and this is one of the things about people who write about patterns. Whenever you're going to try to write about a pattern, you always take this sort of positive view of the pattern, and people start defending the pattern as if they had invented it. Well, you didn't invent it. You're just trying to describe it to other people. And one of the things Brian was mentioning, the big ball of mud, or Joe was mentioning big ball of mud pattern that he did with Brian. Well, I don't know if it happens to Joe, but people often come up and sort of attack Brian as if he was promoting big ball of mud, when instead he was trying to describe it. Now, you want us to make a big ball of mud, but the thing about singleton is it has a fair bit of coupling in it, and in a system like Smalltalk, that is not so bad, because like I said yesterday, Smalltalk is really ideal for that single bounded context, where you have a small number of people who sort of know what's going on, and the coupling is not so bad. So it gets used several places in the standard Smalltalk systems, and it doesn't cause a problem. But it can cause a problem in lots of other places. And when you're trying to build, and you've got this 100 people in a Java project, and you're trying to do everything. Anyway, there are definitely places where it causes problems. But this is getting back to, just because it's a pattern doesn't mean you want to use it on your project.
Ralph, that just reminds me, have you seen the 48 Laws of Power on Groovy Authors? But it's like
48 Laws of what?
Power. It's a catalog of patterns of Machiavellian behavior written by a very smug young gentleman. The book is very beautifully typeset. And each chapter is written according to a pattern, where there's the general statement, and there's an observation of the rule, an observance of the rule, and there's a breaking of the rule. Of course, the breaking of the rule usually leads to a pattern. So it's a very nice pattern. Look, if you're considering doing it.
Yeah, that sounds interesting.
So we're going to thank you very much.
Okay.
So, now.